this video, we will be discussing question number 61 from Chemistry Gate Exam 2022. In this question, we are asked to find out the mean activity coefficient of copper sulfate at 25 degrees Celsius and 1 bar. And the cell given includes copper, copper sulfate, mercury and platinum. The given details are EMF of the cell, which is 0.36 volt, standard electrode potential for copper and mercury sulfate, which are 0.34 volt and 0.62 volt respectively. This kind of an electrochemistry problem can be solved starting from the basic Nernst equation, which connects EMF of a cell to the EMF at standard conditions, temperature, reaction quotient. When we say reaction quotient, that is the ratio of product side ions to the reactant side ions, which is represented like this. And these power terms represents number of moles of those particular ions. C, D, A, B. These terms can be represented in terms of their activity or pressure or concentration. Here we are finding out the mean activity quotient. So we have to represent these terms in terms of their activity. Let's see a reaction where a metal ion is getting reduced to metal form consuming n number of electrons. So the corresponding Nernst equation will be like this. If we are seeing this Q part, that is activity of the metal raised to n divided by activity of the metal ion. For any solid, the activity can be considered as unity. So this equation further reduced to this form. Let's say the reaction is happening at 298 Kelvin. Then this Nernst equation can be further simplified by substituting the values for R, F and T. And that comes like this. E cell equal to E0 minus 0.0592 by N log Q. Coming back to the problem, this cell given in this question has a anodic part containing copper and copper sulfate, cathodic part with mercury sulfate and mercury. And the EMF is 0.36 volt at 25 degrees Celsius. Reduction potentials for copper and mercury sulfate are 0.34 and 0.62 volt. Now let's write the cathodic reaction and anodic reaction. At cathode, mercury sulfate is consuming 2 electrons to get reduced to mercury. At anode, copper is getting oxidized, leaving 2 electrons. Overall cell reaction will be copper plus Hg to SO4 giving copper 2 plus 2 Hg plus SO4 2 minus. The overall cell potential will be reduction potential of cathode minus reduction potential of anode, that is 0.28 volt. Since the reduction potentials are already given in the question, we don't have to worry about changing the signs. We can directly subtract. So now we have in our hand E0 equal to 0.28 volt, E cell equal to 0.36 volt. Now we can substitute the values for Q in the simplified form of Nernst equation, which comes like this. As I already mentioned, for any solid, the unity values will be given for activity. So these 3 terms will be considered as unity and we are left with like this. So as I mentioned earlier, these terms we are representing in terms of activity. This activity terms can be splitted further into activity coefficient and concentration. So activity equal to gamma into M. Thus positive signs indicates cationic part, negative signs indicates the anionic part. So now let's substitute gamma and M values in terms of activity and this comes like this. At this stage, we can connect this into mean activity coefficient values, which is gamma plus or minus. That is the product of gamma plus raised to A into gamma minus raised to B all raised to 1 by A plus B, where A and B represents number of moles of each ions. Here A and B both are equal to 1. So gamma plus or minus equal to gamma plus into gamma minus all raised to 1 by 2. Taking square on both sides of this equation will end up with gamma plus or minus all square equal to gamma plus into gamma minus, which can be substituted here. Similar the case with M and we end up with this equation. If we see this part of this equation alone, this resembles with log x square, which is equal to 2 log x. So this 2 can be taken outside and we can remove these 2's and we have this format of equation now. So let's substitute the value for m, which is given in the question, that is 1 mole per kg. And now we have 0.36 volt equal to 0.28 volt minus 0.0592 volt log gamma plus or minus. After rearranging, we have log gamma plus or minus equal to minus 1.358. Taking an anti-log for this minus 1.358 will give gamma plus or minus equal to 0.044. And that is the answer for our question. So the answer to the 61st question is 0.044. That is the mean activity coefficient for this particular electrochemical cell. For further details, you can refer back to NPTEL lectures, Electrochemical Methods by Professor Debashish Ray. The link is already provided here. Hope this was useful. Thank you.